the difficulty medium, in which we have given the linked list, and each value of the linked list nodes each value we have to replace with the nearest prime number. It is given like if more than one prime number exists, then at equal distance choose the smallest one. Means if the 2 is given, 2 itself is a prime number, so we don't change it. 6 is not prime number, so 7 and 5 both are the prime numbers, so we are replacing with it the 5. Same case, 11 is not prime number, so 9 is also not prime number, so we are replacing with it 11. Same case here also, you can see expected time complexity is big of n into square root of node value. So if we have to find the prime number, then this is the required time complexity. So topic tags are linked list. As we see, the data is given in the linked list format, and the algorithms and mathematical as we have to find the prime number. Let's come to the code. This is the typical code for finding out the prime number. This is typical code of finding the prime number, which finds up to the square root of the number. Now here we are taking the one node to preserve the head. After that we start traversing from here. As we are first checking if the number is itself prime number, then we will not change any nodes value, we will just continue the iteration. Now here we are taking the nodes value in the variable named element, and also taking in the small and large, as we have to find out the smallest and the largest. So for the reference we are taking in this variables. If the smallest is if the small is standing on the 1, means the nodes value is 1. As we know, the nearest prime number from the 1 will be 2, so we are directly changing it to the 2 without wasting any time complexity or time for the execution, and continuing the program. As we have said to we have given the condition that we have to find out the smallest, means nearest prime number, means it can be in the backward and can be in the forward. So for finding in the backward, we are decrementing the small up till until we are finding the prime number, and passing each time the small in this function. In same case we have to find also in the forward direction, so we are passing the large and incrementing until we find the prime number. Finding in the forward direction, here we are calculating the distance from the main node element, means how far we are getting the element from the main value. As we have to replace the nodes value with the nearest element, so we are just comparing the count 1 with the count 2. If the count 1 is less, then we are replacing the nodes value with the small, and if the count value both are the equal, here the condition is you have to replace all the values nodes with the nearest prime number, means nearest is this is nearest, and if the both are on the equal distance, then we have to the smallest one. Here the smallest one will be small, so here the both conditions are covered. When it is less or when it is equal, we are changing it with the small, and in the all other cases we are changing with the large, and here we are moving the forward. Here we are returning the head. Let's run the code. And let's submit the code. All test cases are passed. Thank you so much.